Hello, welcome to my YouTube channel. I built a comprehensive mortgage calculator to illustrate some relatively new features in Microsoft Excel that I am pretty excited about. Those features include dynamic arrays and the let function. So in this video, I will do a quick demo of the mortgage calculator. Then I will do a relatively high-level summary of how the calculations work in the mortgage calculator workbook, and I will follow up with some resources that you can use if you want to do a deeper dive into some of the technical aspects of the mortgage calculator. So with that being said, let's get to this mortgage calculator. The mortgage calculator in question is presented here. In this workbook, we have a fictitious example where we have a house that's valued at $375,000. In this example, the person who this mortgage calculator is for is assuming that they're going to put 10% down on the house, which evaluates out to $37,500. So that will leave us with a house price of $337,000. Now we're assuming a loan, the length of the loan to be 30 years, and you can see some other inputs that we have, what the interest rate would be, what we expect the real estate tax to be, and also what some other costs that's normally associated with a home mortgage, what those costs will be as well. So once we put in those inputs, we can easily see, if we look at the amortization schedule beneath, how that would play out over the course of 30 years if they were to choose a 30-year mortgage. But the nice thing about this particular mortgage calculator is that it is totally dynamic. So if the person that's using this mortgage calculator wanted to go from a 30-year loan to say a 15-year loan, they can easily do so by putting in 15, and you can see how the mortgage calculator beneath immediately updates to a scenario where the length of the loan is 15 years. Another nice thing is, say the person who this mortgage calculator is being used for wants to put down 20% versus the 10% that is illustrated in this example. We can change it to 20% by just multiplying the down payment by 2. So we can just do that here. Now that they have put down $75,000, which represents 20%, we no longer need to pay monthly private mortgage insurance. So we can zero that out, and we can see what those payments will look like if they were to put down 20% versus 10%, and also what it look like, by putting down 20%, how that will affect the payments. So the nice thing about this particular mortgage calculator is that you can easily change your inputs, whether those inputs be the interest rate, the down payment, the length of the loan, or other factors, and the mortgage calculator or the amortization schedule beneath will automatically update based off of the inputs that you chose. Now this was not powerful. This was not possible prior to some new functionality that was added to Microsoft Excel. And that functionality is the addition of the dynamic array formulas, as well as the addition of the let function. So with that being said, let's do a high-level overview of that functionality and how it enables us to build a dynamic mortgage calculator. So we'll start from left to right, starting with the year. If we put our cursor in the cell A13, which represents the first cell for the year, you will see a new function being used there. And that new function there is the sequence function. Now the sequence function, it produces behavior that is very familiar to people who have came from other programming language, or a feature that's available in many other programming language. And that is the ability to dynamically create an array using a function. And in this example, we are creating an array of numbers starting with 1 and ending with the value that is passed to the sequence function. and that and the array is incrementing by 1. So in this situation, we start with 1 and we increment by 1 till we get to the value passed to it, which in this case is 15. If we were to change this 15 to 30, you'll see that the array that is produced is a sequence of numbers that starts with 1, increments by 1 until it reaches the value that was passed to it, which in this case is 30. Now, this functionality is very familiar with people who are coming to Microsoft Excel from, say, the DAX programming language, because you have the generate functions that allows you to generate a sequence of numbers in that programming language. Or if you're coming from R or Python, there are also functions in those programming languages that enables you to have this exact same functionality. So I'm assuming that some of those users were talking to the product team at Microsoft or Microsoft Excel, and they said we need to add this functionality to Microsoft Excel, and finally we have it. So this sequence function is what is being used to produce or populate our year column. The next column that we have here is a column that will calculate the monthly payment, and that simply is a calculation that says that if there is a value in cell A13 in this instance, perform a calculation, and that calculation that would be performed is it will take the total amount that was paid in a year, which is held in column C in the total paid in year column, and it takes that value and divide it by 12 to get what the payment would be on a monthly basis. And you'll see that as you go down this column, it will increment by 1 so that you will reference the right cells or the correct row for the calculation. The next cell that you see, or the next field that you see in the amortization schedule, is the total paid in year. Now, the total paid in year is the sum of all the individual costs that's associated with a home mortgage that's included in this amortization schedule. And that includes column D, which in this case is the total principal paid in year, plus the total interest paid in year, plus the total homeowner's insurance paid in a year, and also added to that is the total private mortgage insurance paid in the year and the total taxes paid in the year. So this cell right here holds the total cost paid in a given year. Up to this point, the functions that we've used, with the exception of the sequence function, are functions that we are very familiar with if we use Microsoft Excel in the past. Now let's go over the calculation for the total principal paid. When we go over this calculation, we will start getting into some of the relatively new features in Microsoft Excel. And this is a very good example of the relatively new let function. Let's expand the formula bar so you can see the complete formula. Now that we have the complete formula shown, we can illustrate this new function. This new function, the let function, is extremely powerful. I like to compare the let function to variables in Power BI. What the let function did for, or has done for, Microsoft Excel users is comparable to what variables have done for Power BI users. And that is, it allows you to break up your calculation into individual logical parts. So in this situation, we are able to first assign the values of the individual variables that's used in our calculation, and then we are able to use those variables to do more advanced calculations. So in this scenario, we start off by just defining some individual variables, and that is things like the year, the interest, the length of the loan, and the loan. Once we have those individual values defined, now we can start performing more advanced calculations. The first advanced calculation we do is the calculations that is required for the payment. That calculation is highlighted here. This expression is used to calculate the payment, and we're able to assign that output to the payment variable. And then now that we have that, the method that we're using to calculate the principal paid in the year is we are taking what the balance was at the beginning of the year, and we're subtracting from that what the balance is at the end of the year. That difference will give us what the principal pay in that year was. So the formula to calculate the balance at the beginning of the year is this expression right here. The expression that we need to calculate the balance at the end of the year is this expression here. Now that we have both of those variables defined, we can easily get what the principal paid in the year by subtracting the starting balance minus the ending balance. This is very powerful. Being able to break up our calculation in individual components will enable us to troubleshoot the formula in the event we needed to troubleshoot. Now, instead of having to have all these complex expressions being used in our final calculation, we're able to build up those individual pieces, and in our expression that we're using to perform our calculation is relatively simple. We know that we are just taking the starting balance minus ending balance, and using the same pattern that's used by the people at SQL BI, I am returning to the let function a variable that represents the output that I want to return, which in this situation is the total year principal variable. Imagine we had to do this particular calculation by just using the complete formula that's required to do this. Not being able to break this up into individual variables like we're able to do in DAX, like we're able to do in other programming languages, would have made this particular function much less readable than what it is. The next column in our amortization schedule is the cumulative principal paid. In this particular column, we are able to use two functions in Microsoft Excel to do this calculation. And in this situation, what we're doing is we're using the subtotal in combination with the offset function in Microsoft Excel to get a cumulative principal paid in the year. So what's happening here is our subtotal function requires two parameters in this, or two arguments in this example. The first argument is the type of aggregation we want to do. 9 stands for sum, so that's telling the subtotal that we want to perform a sum operation over a range that we're going to give it. And then the second argument is the range that we want to perform our aggregation over, and that range is defined with this offset function. So what this offset function is doing is it's saying that we want to start with cell D13. And we're using absolute referencing to make sure that we always start with D13. And the next two arguments are arguments that we'll use if we wanted to modify that position. If we want to modify our row position or our column position, we'll specify that in these next two arguments. But we want to stay, we want our beginning reference point to stay at D13. So we assign both of those arguments a value of 0. And then the last argument, the fourth argument that we're using here is how long we want our range to be. So in this scenario, we are referencing A13, and you see A13 with a hash sign or a pound sign at the end of it. And what that is doing, what that pound sign is saying, is that we're referencing a cell that is the first cell in what is called the output of a dynamic array. So by referencing a dynamic array in this fashion, we are able to dynamically determine what this value is. So if we are in the position that is selected right here, this will return the value that we see in cell A13. If we go down to the next cell, it will return the value that is in cell A14, and so on and so forth till you go down the range. So this is a succinct way of being able to reference the output from a dynamic array in Microsoft Excel. If we go to the next cell, which is the total interest paid in the year, it's similar to what the same logic that we use with the total principal paid in a year. And that is, we build up the individual components of that will be needed for our calculation, and then we perform the calculation and assign the output of that calculation to a variable and use that variable to represent what we want to return from the let function. If we go to the next cell, it's a pretty simple calculation. And this particular calculation, what we're doing is we're calculating what the total homeowner's insurance will be for a given year. And all we're doing right there is taking what the homeowner insurance is on a monthly basis, and we multiplying it by 12 to annualize it. The total PMI, same thing. We're taking what we're paying in PMI and we're multiplying it by 12 to annualize it. And that is followed by the total taxes paid in a year. And pretty straightforward. We're taking what the property value is at the beginning of the year. We're multiplying that by our tax rate to get what the taxes owed would be for the whole year, for that given year. For the house value at the beginning of the year, we're doing something similar that we did before, and that is we start off by building the individual components that we need for our calculation. Then we create the expression needed for our calculation, assign the value of that expression to a variable, and then use that variable as the output that we want to return for the let function. So in this example, we're using this formula here, or this expression here, to calculate what the house value would be at the beginning of the year. Similar thing for the house value at the end of the year in this cell right here. And then for the balance owed at the end of the year, we're just taking what the loan value is minus what the cumulative principal paid is that we calculated in column E to get what is owed. And then the last column in our amortization schedule is what the equity is at the end of the year. And that is a combination of multiple things. One, we take into consideration what our appreciation would be, and we get that by using K13, which as I said earlier, it calculates what the house value would be at the end of the year, and that's based off of what we anticipate the real estate inflation to be for a given year. And then we subtract from that what the balance owed is at the end of the year, and then that difference will give us what the equity would be in our home at the end of the year. Now, I just illustrated what I believe is a very good example of how you can use some of the relatively newer features in Microsoft Excel to do some amazing things. So if you want to do a deeper dive of how each one of the calculations work in the example that I went over this, in this mortgage calculator, you can go to the GitHub site that I have for this particular video, which is shown in the link in bullet point 3. At this GitHub site, you have access to the Excel workbook that was used in this demonstration, along with some links to some resources that will enable you to learn more about how the functions work that were used in this Excel workbook. I hope you found this material useful, and I look forward to producing more content for you. Thanks a lot.